My name is Abhijit Jahov. I provide engineering support for the refining customers. The VPD is a unique solution, making it possible to refine heavy crude oil with economical outcomes similar to a light crude oil grade. The current VPD in production is compliant with ANSI and API standards and can be installed at the hazardous locations defined by OSHA as Class 1, Division 1 locations. The VPD uses a patented method of electromagnetic and hydroacoustic technology. By using electric energy, the electric motor produces a mechanical energy, which is an energy source for the unique hydroacoustic and electromagnetic technology, allowing the movement of tar asphaltenic components from the residue to the distillates during the crude oil transferring.
The impeller located in the VPD casing has a unique configuration of vanes. The vanes move the crude oil to the radial walls of the VPD casing and create hydroacoustic vibrations in the crude oil. The radial walls have a high-frequency conductor charged with current. The conductor emits the current into the crude oil. Thus, due to combined application of hydroacoustics and electromagnetic treatment, there is a movement of tar asphaltenic components from residue to distillates. The VPD moves modified crude oil to the storage tank for incubation. Crude oil is of colloidal structure. Long-chain molecules have a tendency to create bonds, including hydrogen bonding. It took millions of years for the hydrocarbons to create such bonds in the underground reserves. After the exposure to hydroacoustic and electromagnetic technology, the bonds between the long-chain molecules become weak. Parts of long-chain molecules either separate on their own or due to small molecules bumping between weak links of the long-chain molecule. As a result, the separated parts of long-chain molecules move to distillates. The separated molecules, by their physical properties, such as the size and the molecular weight, are similar to diesel and gas oil. Thus, there is a reduction of less desirable residue and increase in the distillates through the addition of diesel and gas oil. The refinery receives shipments of crude oil either by pipeline or delivered by other means of transportation. The refinery has a storage capacity that allows storage of crude oil between shipments and maintains a reserve capacity of 15 to 20% of the annual throughput volume. The existing charge pumps are used to transfer the crude oil from storage tank battery through the desalter and to the inlet of the refinery. The VPD units are installed between the desalter and the portion of the storage capacity necessary for incubation of the modified crude. The charge pump moves crude oil to the refinery for refining from the incubation tankage. When the first incubation tank becomes empty, the valves are switched and the second incubation tank is used to supply the refinery with the crude oil. Meanwhile, the VPD equipment fills the first incubation tank with crude oil. When the second incubation tank becomes empty, the valves are switched and the third incubation tank is used to supply the refinery with crude oil. Meanwhile, the VPD equipment fills the second incubation tank with crude oil. When the third incubation tank becomes empty, the valves are switched and the fourth incubation tank is used to supply the refinery with the crude oil. Meanwhile, the VPD equipment fills the third incubation tank with crude oil. If the top three ranking companies were to install the VPD equipment at their existing refining capacities, which combined constitutes roughly 1/8 of the world current refining capacity, the earnings per share will increase 30 to 50%, or 64 cents to $1.75 in a dollar equivalent per share. If the companies do not choose to announce dividends, the increased revenues will most likely increase the market value of the stock.
My name is Dr. Gautam Chakrabarty. I am a chemical engineer and a technical consultant for Viscoil. Last 44 years, I have worked in chemical and petrochemical industries. I have done my graduate and postgraduate research work at UCLA. The Viscoil technology allows several positive effects for the refiners specializing in production of various fuels. Among the positive effects are extract additional volume of valuable distillates without use of any chemical or additional thermal energy process during atmospheric or vacuum distillation. Recover high quality distillates, namely diesel and gas oil of high purity that do not lack hydrogen as opposed to distillates received outside of the atmospheric vacuum distillation process. Use additionally gained gas oil to produce gasoline or diesel. Obtain additional amount of expensive diesel fuel where typically refined volume of diesel depends on the physical properties of the used feedstock crude oil and not the refining process itself. If we look at the simplified process that takes place at the refinery, we'll see the following advantages Viscoil technology brings to the refiner. In the atmospheric vacuum column, there will be an increase in diesel oil as well as gas oil that do not require further alteration of hydrogen to carbon ratio. Therefore, there is a reduction in vacuum residue. Hydrotreating reactor, there will be an increase in low sulfur diesel and H2S received from the reactor. For FCC unit, there will be more gasoline produced from the isomers which do not have a carcinogenic nature as a naphtha-based gasoline containing aromatics. The blending of naphtha-based gasoline with the increased volume of gas oil-based gasoline allows to maintain the aromatics concentration and reduce amount of naphtha used to produce different polymers. Coking reactor. There will be reduced amount of coke and spent less energy to produce coke gas oil, as majority of gas oil was received during atmospheric vacuum distillation.
Let's take an example for one country that produces medium and heavy crude. If the country adapts Viscoil technology among its 3 refineries, distillation yields increase by 9.6% for medium crude and by 6.3% for heavy crude. As a result, revenue from installation of Viscoil technology for all 3 refineries will increase by $1.2 million per day, which adds up to approximately $411 million per year.
Adaptation of Viscoil technology will provide results similar to the following. By conducting D86 analysis, recovery increases from 52% in the source crude to 60% for modified crude. By conducting D445 analysis for viscosity 25 degrees Fahrenheit above the pour point, viscosity decreased from 112 centistokes in the source crude to 85 to 90 centistokes in the modified crude.
Such test results clearly show the movement of heavy, highly viscous components into lighter, less viscous form. This is representative of the number of tests conducted to provide quality assurance of the Viscoil technology process.